Hello students, welcome to my class. Today we are going to discuss few questions related to chemical kinetics, and this time my pattern is JEE advanced pattern. Slightly tough, but we will make it easy for you. Clear? Now read the question carefully. What is given here? That is, the reaction A gives you product at this question, and K is the rate constant, is a zero order, while the reaction B, which gives a product, again the rate constant is K, is of first order. Now the question is, for what initial concentration of A are the half-lives of two reaction equal? That is, we have to relate the half-lives of reaction A and reaction B, but the question is telling that is one is zero order and the second one is first order. So let's start the battle. That is the solution of the question. Listen carefully what I am telling. For zero order reaction, we know that is rate is independent of the concentration, that is x upon t is equal to k and x is equal to kt. If t is equal to t half, then assume x is equal to a by 2 and a is here nothing, that is the initial concentration. Clear? Now put this value, that is a upon 2 is equal to k t half. Clear? Now what will happen? Check it out. That is t half is equal to 2k, wait for a moment, 2k, wait, 2k t half is equal to a. This is the equation I am moving here, check it out. T half will be equal to a upon 2k. This is the expression for t half for first equation. Now let's move to the next one. Next one is given here, that is the first order. For first order reaction, T half is equal to, we people know, ln 2 upon k. Assume this is the question number 1 and this is the question number 2. Yes, sir. Now according to the question, what is given? For what initial concentration the half-life of two reaction is equal? Now put the value from equation 1 and equation 2. What do we get? Wait for a moment. That is a upon 2k is equal to ln 2 upon k. This will cancel this one and we people can say a is equal to 2 ln 2, ln, that is the exponent, or it can be represented like a is equal to ln 2 to the power 2 ln 4, or it can be written like this, log E4. Am I right? The final answer is log E4. Now I am moving here, check it out. Now look at the option here, that is, what is the correct option? This is the A. For question number 1, A is the correct option. Clear? Now I am going to rub this part and we will discuss the few questions. Now let's move to the next question, that is the question number 2. Read the question carefully what is given here. If homogeneous catalytic reaction follow three alternative paths A, B and C, then which of the following indicate the relative ease with which the reaction occurs? As we know, if there is a less requirement of activation energy, the reaction will move faster. By using the graph during my lecture, I have discussed, if we draw the graph between potential energy and reaction coordinate, that is, this slope will give you the activation energy. Look at, if I talk about C, it requires less amount of activation energy to proceed. If I talk about B, it will require slightly more than C. And if I talk about A, it will require more activation energy in comparison to B and C. So according to the theory, less activation energy, faster is the reaction. So what is given here? Which of the following indicate the relative ease with which the reaction proceed? So we can say first comes C, then there comes B, and then there comes A. So we can easily observe that is for question number 2, B is the correct option. Am I right? Yes, sir. Now I am going to rub this part and we'll discuss the next question. What is the next question? Check it out. That is third. For a second order reaction, okay, a plot of log T half versus log A will give an intercept equal to which of the following? That is, we have to find the intercept in this case. First of all, for second order reaction, we people know K is equal to 1 upon T into 1 upon A minus X, clear to you, plus 1 upon A. This is the term. Now the question is, if T is equal to T half and X is equal to A by 2, now what will happen? Check it out. Then put here, that is K is equal to 1 upon T half, 1 upon A minus A by 2, clear to you, is 1 upon A. Clear? Now T half is equal to 1 upon K. After solving, what do we get? That is 2A minus A, that is A, and 2 will move here, 2 upon A minus 1 upon A. Clear to you? Now moving here and check it out, that is T half is equal to 1 upon K into LCM, that is gives you A, 2 minus 1, that is 1 minus A. One more thing, that is put here minus. Clear? That is T half will be equal to 1 upon K into 1 upon A. Am I right? 1 upon K into 1 upon A. Now what will happen? One more thing, taking log both sides. Taking log both sides, and in this case, if I take log both sides, that what will happen? Check it out, that is log T half, log T half 1 upon K, that is, if I take the log in both the cases, that is, it will give you minus log K and minus log A. And now according to the question, what is given here? If we draw the graph, between log T half and log A, then what? I am moving here, check it out, that is log T half versus log A, and where A is the initial given intercept, we have to find the intercept. Now listen carefully, this one is definitely Y and this one is definitely X. and minus 1, that m slope is minus 1. That is, if I draw the graph of log A and log t half, then definitely the slope will be, the graph will be like this, and this one is m according to the question, because, and this one is c, because y is equal to mx plus c is the expression. Here we obtain x is equal to log A, so slope m is equal to minus 1, that is the graph will be like this, and intercept c is equal to minus log k. So what is the intercept? Minus log k. If I talk about the magnitude, then this is the answer, and if I talk the exact figure, that is, it is not log k, it is better to represent minus log k. Clear? This is the detailed solution for question number 3. Now I am going to rub this part and we will discuss few more questions. Wait for a moment, friend. Question number 4. Read the question carefully. For a reaction taking place in 3 steps, the rate constant are K1, K2 and K3. The overall rate constant K is equal to K1 into K2 upon K3. If the energy of activation values for the first, second and third are 40, 50 and 60, then the overall energy of activation is very simple. Now what to do? Check it out. I am giving you a detailed solution for this question. What given? K is equal to K1 into K2 upon K3. We people know, remember, K is equal to A E A upon RT. This is the Arrhenius equation. Remember, now put this value here. Now check it out, what will happen? Look at A E A upon RT is equal to, for K, A E A 1 upon RT. Now multiply by A E A 2 upon RT, yes sir, divided by K3 A E A 3 upon RT. Exactly? Yes sir. Now come here, what I am telling. A E A upon RT is equal to A E E A 1 then minus E A 2 upon RT. Can I write like this? Yes sir, definitely you can write like this, because when base same, power add each other. Now A minus E A 3 upon RT. What will happen? This will cancel this one. Am I right? One more thing we can do, because we have to also cancel the this value also. So it's better to write like this. Do not need to put here A and A. A also here, now A also here. Now move here, what will happen? and given the overall energy of if the energy of activation value of for first, second and third reaction. Okay, is it okay? AEA upon RT, AEA upon RT, okay, then upon K3, that is AEA upon RT. Overall rate constant K, and the rate constant if the energy of activation value were for first, second and third. Overall what we write here, that is AEA upon RT. Clear to you? The next one is we can write here, that is, this will cancel this one. Now AEA upon RT is equal to E minus EA1 minus EA2 and minus plus EA3 upon RT. Now when we compare these two, what we get, that is EA is equal to EA1. What is the value of EA1? That is 40 minus 50 and plus 60. Am I right here? Check it out if there are any problem regarding the question. That is EA1, EA2 and EA3, 40, 50 and 60 for first, second and third, 40, 50 and 60. Check these things, friend. If there is any mistake related to the minus 40, clear to you? That is minus 90 plus 60, that is minus 30 kilojoule per mole. Clear? There is EA, this will cancel this one. Overall magnitude is plus 30 kilojoule per mole. So I am moving here, check it out. For this expression, we people can say the answer is A. Now check out the detailed solution again. K is equal to K1, K2 and K3. Okay, and K is equal to AEA upon RT and K1 is equal to AEA upon RT1 into AEA upon RT2. Here the multiplication. So one more thing, we have to put A square. This will cancel and this will cancel this one. Overall they will cancel each other. That is AEA upon RT. So EA is equal to EA RT will cancel each other, minus EA is equal to, that is finally EA is equal to plus 30, that is kilojoule per mole. Now I am going to rub this part and we will discuss the next question. Wait for a moment. Now the next question is question number 5. Activation energy of forward and backward reaction are 60 kilojoule and 40 kilojoule. Which of the following are true? It is endothermic, exothermic. That is, we need to find the heat of reaction. That is delta H is equal to forward minus backward. Yes sir. Forward given value is 60 and backward given here, that is 40. So delta H is equal to plus 20 kilojoule per mole. Definitely by using this data we can answer the question. Heat of reaction and the threshold energy, the sum of all 60 plus 40, that is 100, and here delta H is positive, that is definitely it is an endothermic reaction. So for this question A, C and D are the correct option. If you do not reverse the direction, if you reverse the direction, then it will be treated as a exothermic reaction also, but nothing mentioned here. So we can say the best possible answer endothermic, that is A, C and D. Clear? Now I am going to rub this part and we will discuss the next question. Wait for a moment. Now let's move to the question number 6. This is very simple question, the integer type. The rate of reaction at 10 seconds. Look at, when time changes, rate never changes, it is almost remains same. That is, as I told you, during any reaction, if time changes, then that is, if time increases from starting from 0 to 10 second to 20 second, from 50 second, 100 second, that is the concentration decreases. If concentration decreases, definitely that is rate of reaction changes, rate changes, and ultimately the value changes. But in this question, that is, it proves that the rate is independent of the concentration of the reactant. That means to say, remember the things, if rate remains same when time consumed, that is, it is independent of the concentration. And which order is independent of the concentration of the reactant? That is 0 order. Clear? So for this case, we people can say the answer is 0 order reaction. Am I right? Yes sir, you are absolutely right. That is the 0 order reaction. I am going to rub this part fastly and we will discuss the next segment of the question. What is the next segment? That is question number 7. I am leaving this question for you. This is one of the simplest question. This is a previous year IIT JEE question. 2N2O5 which gives 4NO2 plus O2. The concentration of the reactant decreases exponentially with time. Definitely this is a correct decrement. And the half life of the reaction decreases with increasing temperature. This is also correct. The half life of the reaction depends on the initial concentration of the reactant. Second order in this case, and here the reaction is of first order. The half life of a reaction depends upon the initial concentration of the reactant. This one is not correct. Half life, first order reaction. Clear? The reaction proceed to 99.6 completion in 8 duration. This is also correct. So for this question, we people can say that is A, C and D are the correct option for this question. Clear to you? Again I am repeating, that is what I am telling for this question, that is what are the correct option, that is A, B and D. C is wrong. So A, B and D are the correct option. I am going to rub this part and we will discuss the next one. Wait for a moment. That is question number 8. Match the following. First order reaction. As we know, for radioactive decay, that is the first order reaction. So for question number A, R is the first choice. Second one, look at the concentration changes but T half does not change. That is, we know in first order reaction half life period is independent of the initial concentration. So for A, R and S is the correct option. Now for second order reaction, check it out. For second order reaction, look at T half here given. As we know, T half is, the relation is A naught to the power n minus 1. For 0 order reaction, T half is directly proportional to initial concentration. For second order reaction, T half is inversely proportional to initial concentration, and for first order reaction, T half is independent of the initial concentration. So in this case, where look at concentration decreases but T half increases, inversely proportional. So for second order, Q is the correct. 0 order reaction, directly proportional, that is 0.1. That is, if concentration decreases, T half also decreases. So for C, P is the correct option. Now for question number D, T half inversely to the inversely, this is the condition of second order. Condition of second order. So second order, this represent, so Q. Now check it out. These are the correct options related to this matrix matching. A, R and S, B, that is Q, C, that is P, and D, that is Q. Am I right? Yes, sir. Now I'm going to rub this part and let's move to the next segment. What is given here? Check it out. Now, the question number 9, look at. This is a passage. Read the question carefully. CO plus NO2, CO2 plus NO, this is the figure, and this one is energy of activation, this one is heat of reaction, and X plus Y plus Z is the threshold energy. By observing this passage, we can assume such things. Now, what is given here? Activation energy of the forward reaction. As I told, the activation energy of the forward reaction here is X. So, for question number 1, that is A, that is the first part of the question number 9. Now, activation energy of the backward reaction. As we know, delta H, what is given? Delta H is equal to activation energy of forward minus activation energy of backward. This is delta H, Y, and activation energy of forward is X, and so activation energy of backward EB will be equal to, tell me what will happen if it moves here. One more thing, that is Y minus X. Am I right? No. That is X minus Y. This is the things here. But one more thing I am going to mention here, that is in this question, that is the according to the situation, the activation energy of backward reaction, if it is if you do not use the negative sign, if it is exothermic reaction, because this equation shows that there is a liberation of heat. So, put here minus sign. Sometimes you get mistake. This is the exothermic reaction. Clear to you? Now, so EB is equal to not X minus Y. It will be equal to X plus I. So, be careful for solving such kind of question. So, the answer is not X minus Y, that is X plus Y. Now, let's move to the next one. The heat of reaction, that is Y, mentioned here, and what is the threshold energy? We people know the threshold energy is very simple, X plus Y plus Z. So, this is the fourth part, we can say C is the correct option, X plus Y plus Z. Am I right? Yes, sir, you are absolutely right. I am going to rub this part and let's move to the next segment, that is the final question of this session. Now, read the question carefully. This is first order growth kinetics. Suppose 50 bacteria are placed in a flask containing nutrients for bacteria so that they can multiply. A study at 35 degrees Celsius gave the following result: 0, 15, 30, 45, 60, 100, 200, 400, 800 and 1600. Clear? Now question, the rate constant for the first order growth kinetic. This is a simple formula. During my lecture I have derived this expression, that is K is equal to minus 2.303 upon T log A upon A plus X. That is for the first part of question number 10 is F. Now, what is the unit of first order? That is first order, and we know first order, that is the unit is per second, here is minute, that is per minute. So, the second part have answer, that is A. Now, the rate constant, here is given the rate constant for the reaction. As I told you, what is the expression for rate constant? Check it out. So, the K is equal to minus 2.303 upon T log A upon A plus X. Clear? Now, data, that is, if I take this interval, same interval, 100 plus 200, that is A is 100, put minus 2.303 upon T, 0 to 15, put here 15, and log A plus A is 100 and A plus X, that is the gap between them, that is what will happen, 100 plus 200, that is 300. A plus X, 100 plus 100, that is 300. Now this is the expression, k is equal to minus 2.303 upon 15 log 1 upon 3, that is growth. If I take this interval, now we have many more things I have to add. You can also take this interval, this interval, this interval also, that is the each and every interval, what is the gap here. Now put this expression here, you can also take, and finally what will be the answer in this case, that is the answer will be 0.0462 per minute. A is the correct expression here. Clear what I am telling? A is the correct, 0.0462 per minute. Now what is the rate? That is 0.042 rate, that is multiply, that is will be 4.62 bacteria per minute. From where did you get? That is 0.0462 multiply by 100. What will happen? That is 4.62 bacteria per minute. So for this question, that is the 4, that is A is the correct option. Am I right? Yes sir, you are absolutely right. Wait for a moment. Now this is the data, and sometimes we take also, during solving the question, we take also the average of this data. So we have to mention such things during the question. So this is the final one, final question for today's lecture. In my next lecture, I will discuss few more things related to the population, related to the chemical kinetics. Clear? So let's review the things. Look at, for question number 1, A is the correct option. For question number 2, that is B is the correct option. For question number 3, D is the correct option. For question number 4, A is the correct option. For question number 5, that is endothermic, A, C and D is the correct option. For question number 6, 0 order. For question number 7, that is, this one is wrong, that is A, B and D are the correct option. For question number 8, I have discussed, that is P and in this case, that is first order, that is R and S. For second order, that is Q. For 0 order, that is P. For D, that is Q. Clear to you? Now next one, for question number 8, as I told you, this is X, A, that is X plus Y. Next one is Y, and this one is X plus Y plus Z, and I have discussed this question. So time has come, friend, time to say bye bye. Thank you so much.